Welcome guys. In this particular video, we are going to be talking about vector resolution. In our last class, we talked about the unit vectors, right? And we said that we have scalar vector, we have scalar quantity and vector quantity. So scalar quantities are quantities that has only magnitude but no direction, while vector has both magnitude and what? Direction. So in scalar quantity, when we are adding two or more scalar quantities together, we don't take into consideration the direction because scalar quantities have only magnitude, no direction. So therefore, we can use the normal simple arithmetic in adding two or more scalar quantities together. For example, if you have two lengths, length 2 meter plus length 3 meter, that's just what? Length 5 meter. But in the case of vector quantities, we are going to be considering the magnitude and the what? Direction. So for vector quantities, we cannot add them by using basic arithmetics. So the method we use is what we refer to as vector resolution or vector addition. So therefore, let's talk about the vector resolution. We have different cases for vector resolution. The first case we are going to be talking about is for two parallel vectors. So guys, the first case I'm going to be talking about is for what? Two parallel vectors. The first thing you have to understand about this is that for two parallel vectors, number one, their angle theta is equals to what? 0 degree. So guys, if they ask you that for parallel vector, what is the angle between them? The angle is what? 0 degree. Number two, their resultant equals addition of the two vectors, addition of the two vectors. So for example, let's say we have vector 1 and vector 2. Let's say we have force 1 and force 2. The resultant, if they are parallel, is going to be what? F1 plus what? F2. So for the case 2, this is case 1. For the case 2, this is for two anti-parallel or opposites vectors. So guys, when two vectors are anti-parallel or opposite, their angle theta is equals to 180 degree, and their resultant is equal to subtraction of the two vectors. So guys, let's say we have force 1 and force 2. The resultant of the two forces is going to be F1 minus F2, or R is equals to F2 minus F1. So if you are looking for the resultant of two forces, it's going to be the bigger force minus the smaller force. So if the force 1 is greater than the second force, it will be F1 minus F2. But if the force 2 is greater than the second force, it will be what? F2 minus F1. Okay guys, the next one is case 3. This case 3 is for perpendicular vector. Guys, if two vectors are perpendicular, their angle theta is equals to 90 degree. And also, their resultant is calculated by using the formula F1 squared plus what? F2 squared. This is by using the what? Pythagoras theorem. The case 4. Calculation of resultants. When two vectors have acute angle less than 90 degrees or obtuse angle that is greater than 90 degrees. So when two vectors has acute angle, that is if the angle between them is acute, which is less than 90 degrees, or obtuse, greater than 90 degrees, the resultant is calculated by using this cosine formula: f1 squared plus f2 squared plus, it will still be plus, 2f1 f2 cos theta. So that is that about what? About that, guys. So guys, let's look at some example in these cases. For this case, so guys, the example we have here is that if given two vectors, f1 is equal to 5 Newton and f2 is equal to 7 Newton, find the resultant if this. So guys, just write solution. The first force, F1, equals 5 Newton. The second force, F2, equals 7 Newton. So we are looking for resultants if they are parallel. Guys, if they are parallel, the resultant of the two forces is going to be the addition of the two. So the resultant is going to be F1 plus F2. That equals 5 Newton plus 7 Newton. And that equals what? 12 Newton. So when two vectors are parallel to each other, their resultant is going to be the addition of the two vectors. Number two, we have to calculate if they are anti-parallel. When they are anti-parallel, it's going to be subtraction. But it's going to be the highest force, the greatest force minus the lowest force. So that is F2 minus F1. That is F2 minus F1. That's equals to 7 Newton minus 5 Newton. And that's equals to what? 2 Newton. And we are asked to calculate the angle between them. You have to calculate the find a resultant if the angle between them is 35 degrees. So therefore, you just say R is equals to, whenever the angle between them is acute, less than 90, you're going to be using the formula R square root F1 squared plus F2 squared plus 2F1 F2 cos theta. So your R is going to equals to square root your F1, that is 5 squared, plus your F2, that is 7 squared, plus 2 times 5 times 7, because the angle is what? 35 degrees. So you're going to press this on your calculator. You will press the square root. Press square root 5 squared plus 7 squared plus 2 times 5 times 7 cos 35. And the final answer is going to be 11.46 Newton. So if the angle between them is 135, you will still use this formula. R equals F1 squared plus F2 squared plus 2F1 F2 cos theta. So your R equals square root. Your F1 is 5, that is 5 squared, plus your F2 is 7 squared plus 2 times 5 times 7, cos your theta is what? 135. So also put our calculator, press square root 5 squared plus 7 squared plus 2 times 5 times 7 times cos 135. Close the bracket. That is equals to, you're going to get 4.95 Newton. So that's how to do it. Then let's look at another example before I move. The example 2 we are going to be talking about is this. They say an isect is displaced on a straight track, joining the base and the apex of two vertical poles. Guys, let's write solution. So guys, let's say this is the first pole, this is the second pole. two vertical poles. This is the first pole, this is the second pole, each of 2 meter high. The height of this is 2 meter. This is also what? 2 meter. And 3 meter apart. The distance between them is 3 meter apart. Calculate the straight track covered by the insect. So according to what we have here, we can draw this. So the next thing you have to understand is that this is called the resultant. This is the angle 90. This is the theta. I'm going to take out one part of this as this. This is the angle theta. This is 90 degree. This is 2 meter. This is 3 meter. So the straight track covered by the insect is the resultant that is joining this with the base. So I have to look for this resultant. So whenever you have two perpendicular vectors and you have to look for the resultant, you can just use the Pythagoras theorem here. This is the hypotenuse. This theta facet is the opposite. And the last side is the what? Adjacent. So I'll just say R equals, okay? Using Pythagoras theorem, hypotenuse squared equals the opposite squared plus adjacent squared. Our hypotenuse is R. That is R squared equals opposite. Our opposite is 2 squared plus our adjacent is 3 squared. That simply means 4 plus 9, and that's equals to 13. Then the R is equals to square root 13. So root 13 gives us 3.6 meter. So to calculate the angle above the horizontal, I am to use this. You know this is the opposite, this is the adjacent. So to calculate this angle, I will just say tan theta equals opposite over adjacent. Tan theta equals 2 over 3. Theta equals tan inverse 2 over 3. And theta equals, if you press tan inverse 2 over 3, we are going to be getting 33.6 degrees. So that's about that, guys. So let's move on to the next aspects. So guys, we will firstly be talking about some aspect of bearing. Guys, we all have to understand this. This up is the north, down is the south, to the right is the east, to the left is the west. So in some cases, follow me guys, if I have an expression like north 30 degree east, how can I represent this on the cardinal points? This is guys, you are going to draw this, indicating the north, east, west, south. Firstly guys, the angle is 30 degrees. It is formed between north and what? East. So this simply means the angle is going to be between these. So it's going to be between these. So they say north. After north is what? 30 degrees. This is north. After north is what? 30 degrees. So this simply means north, 30 degrees, east. Also guys, if it was, let's say it was south 60 degree west, if you also draw the 4 cardinal points, this is the north, south, east, west. They say south 60 degree west. That simply means the angle is between south and west. But they say south 60 degrees. This means that after south is what? 60 degree. The next aspect is this guys. say we have 30-degree north of east. Before you can approach this, firstly change it. Rewrite this expression as 30-degree north from east. Change the off to what? From. We also draw the 4 cardinal points. Indicate the north, south, east, west. Firstly, guys, this 30-degree is also between north and what? East. So this simply means the angle is going to be between here. But now, this expression here is different from the 2 examples we've done here. This 30-degree north of east simply means 30-degree north from east. Since they say it is coming from east, that simply means we are going to do it like this. So this is where you are going to place the 30-degree. So you have to understand this very well. Let me do another example on this. Let's say we have 60-degree west of south. You will also rewrite it as what? 60-degree west from south. We will also draw the 4 cardinal points. Indicate the north, the south, the east, the west. This 60-degree is between west and what? South. This is west, this is south. So the angle 60-degree is between what? West and south. So therefore they say 60-degree west of south. Change this off to from. So that is 60-degree west from south. That simply means it is coming from where? South. So it is coming from south. So this is where you're going to put the 60-degree. So understand this very well. Then let's move on to the case 5 now. So guys, there are rules that you have to take into consideration before you can do any question that involves vector resolution. These rules are to be at the back of your hand so that you will not forget easily. The first rule is that you have to identify the positive x-axis, negative x-axis, positive y-axis, and what? Negative y-axis. Then all angles must be to the horizontal. Then you have to resolve all forces to the horizontal direction by taking cosine. We also resolve all forces to the vertical direction by taking sine. We will calculate the resultant by using this formula. We will calculate the angle by using this formula. A typical example we are going to be talking about now is this. This is the jump question. So the question is this. They said we have 4 forces as shown in this diagram. Calculate the resultant of the 4 forces. Guys, we write solution. This diagram given to us, we are going to redraw it as it was given. 3 root 3, that's Newton. 10 Newton, 30-degree, 3 Newton, 6 Newton, 60-degree. We are going to redraw this. Guys, once we've redrawn this diagram, the next thing we have to do is to follow the first step. We have to identify the positive, negative axis. Guys, the vertical direction are the y-axis, while the horizontal direction are the what? X-axis. So, if it is going upward, we will put plus there. So, going upward, that is a positive y direction, but going down, this is the negative y direction. So you are going to indicate, put plus here, put minus here. And to the right side, when it is going to the right, that is also be positive. But if it is going to the left, that would be what? Negative. So we are going to indicate the positive y direction, the positive x direction. So after we've done that, the next thing we should do is to convert all angles to the horizontal. So the first angle given to us is 30 degrees, the second one is what? 60 degrees. They are all to the horizontal. They are already to the what? To the horizontal direction. So if any angle wasn't to the horizontal, I'm going to convert it to the horizontal by minusing it from what? 90 degrees. But since the first angle is 30 degrees and it is to the horizontal, I don't have to convert it again. The second one is 60 degrees and it also is to the horizontal, I don't have to convert it again. So therefore, guys, the next one is resolve forces to the horizontal and vertical direction. So follow me as I'm doing it, guys. I will draw something like this. Here I'm going to write horizontal direction. Here I'm going to write vertical direction. So I'm going to be resolving all my angles to the horizontal direction and also to the vertical direction. So guys, whenever I'm resolving to the horizontal direction, guys, I'm going to be taking cosine. But when I'm going to the vertical direction, I'm going to be taking what? Sine. So therefore, I have 10 Newton here. This 10 Newton has this angle 30 degrees, which is to the horizontal direction. I will firstly resolve this 10 Newton to the horizontal direction. Follow me, guys. This is the 10 Newton. I will firstly write it here 10. Here also, I'll also resolve this since it has angle 30, 10. Guys, this is the positive horizontal direction. This is the negative horizontal direction. If I'm to resolve this 10 Newton to the horizontal direction, it is going to be going to this positive direction. So this simply means the plus that is here, I will put it here. So whenever I'm resolving to the horizontal direction, I'm going to be taking cos. So this is cos. The angle is what? 30 degrees. Also, this is the positive y-axis, this is the negative y-axis. If I'm resolving this 10 Newton, it's going to be going to the positive y-axis. So I will also put plus here. Sine. So if I'm resolving to the vertical direction, I'm going to be taking what? Sine. So that will be 10 sine. The angle is still what? 30 degrees. Do not forget, the angle must always be to the what? 30 degrees. The next one I have here is 60 degrees, 6 Newton. So this 6 Newton has 60 degrees. I'm going to be resolving this 6 Newton to the horizontal direction and the vertical direction. 6. If I'm resolving to the horizontal direction, don't forget that the angle must always be to the horizontal. So if I'm resolving this 6 Newton to the horizontal direction, I'll be taking cos. The angle here is what? 60 degrees. I'm going to write this 60 degrees. Okay? Now, you notice that if I should be resolving this 6 Newton to the horizontal direction, it's going to be to the negative horizontal, not positive. So this 6 Newton is going to be going to the negative horizontal, so I'm going to put negative here. But if I should resolve this 6 Newton to the vertical, it's going to be going to the negative vertical, not positive. It's going to be going to the negative vertical, so I'm going to put what? Negative here. Negative 6 sine 60. So whenever I'm going to the vertical, I'm going to be taking what? Sine. Now, the other thing we have here is that you see that we only have 2 angles here, but we have 4 forces. The first one is 3, 10, 3, 6 Newton. This 10 Newton has 30 degrees. This 6 Newton has 60 degrees. But this 3 Newton, it is already going in the horizontal direction. This 3 Newton has no angle. It is going in what? Horizontal direction. That is going in a parallel way. So the angle will be 0. So this 3 Newton is going in the horizontal direction. It has no vertical direction. When you are moving in the horizontal direction, that simply means you are not moving in the what? Vertical. You are moving in what? Horizontal. So for this 3 Newton, it only has the horizontal direction. It has no vertical direction. And it is moving in the positive horizontal direction. So I will just say, for 3 Newton, just be plus 3. You just write as what? Plus 3. But for the vertical direction, for this 3 Newton to be what? 0. Because this 3 Newton has no vertical direction. Because it is moving in what? Horizontal direction. it remains 3 root 3 Newton, guys. This 3 root 3 Newton is also moving only in the vertical direction. This 3 root 3 Newton is moving in what? Vertical direction. Since it is moving in the vertical direction, that simply means it has no horizontal direction. It has what? No horizontal direction. So this 3 root 3 Newton, the horizontal direction is going to be what? 0. While the vertical direction is going to be what? Plus 3 root 3. So this 3 root 3 Newton is moving in the what? Vertical direction. But it's moving in the what? Positive vertical direction. It has no horizontal direction. So once we are done with this interpretation, then we are going to add everything together. So the horizontal direction, we are going to be looking for the addition of everything. Summation x. This summation simply means, this sign means summation, and it means to add everything together. This x is for the horizontal direction. We also look for the summation y. This also means to add everything together in the y-vertical direction. So we are going to press it on our calculator. 10 cos 30 degree minus 6 cos 60 degree plus 3. This is going to give us 5 root 3. Why this will give us 10 sine 30 degree minus 6 sine 60 degree plus 3 root 3. This will give us 5. So therefore, guys, we are going to calculate the resultant by using this formula. Our resultant equals root summation x squared plus summation y squared. Your r is equals to square root summation x, that is 5 root 3, that is 5 root 3 r squared plus summation y 5 plus 5 squared. So guys, we are going to press that on the calculator. Root 5 root 3 r squared plus 5 squared. Then our resultant is 10 Newton. So that is the final answer for the resultant. But if you want to calculate the angle, guys, if you want to calculate the angle, look at what I'm going to do here. You know the answer we got is not negative. This simply means this one is positive. This is also positive. So I can do the angle in 2 ways. I can use this formula to calculate the angle. My theta will just be tan inverse summation y over summation x. My theta equals tan inverse, our summation y is 5, that is 5. Summation x is 5 root 3, 5 root 3. Then my theta is equals to, we are going to press it, tan inverse 5 over 5 root 3. That will give us 30 degrees. Our theta is equals to what? 30 degrees. But also, we can use the other method. The other method is, I will write the vector or equation or the vector diagram for this. You know the summation x we get is positive. That simply means it is moving in the positive direction. Positive direction. That is plus 5 root 3. And our summation y is so positive. That simply means it's so moving in the positive y direction. That is plus 5. Then I can connect this to this. The connection of this vertical to the horizontal is known as the resultant. This is the angle 90, and I represent this as what? Angle theta. This is the angle to the horizontal. So in order to get my resultant, I can just use the Pythagoras theorem, or yes, I can use the Pythagoras theorem. This theta faces, this angle 90 faces here, this is the opposite. This theta faces here, this is the what? Sorry. This angle 90 faces here, this is the hypotenuse. This theta faces here, this is the what? Opposite. Don't forget the value here is what? 5. The value here is what? 5 root 3. And this is what? Adjacent. So using the Pythagoras theorem, hypotenuse squared is equals to opposite squared plus adjacent squared. Hypotenuse squared, that is r squared, Okay, don't forget, wait, sorry guys, I've gotten my arm to be 10 already, right? That is 10 Newton already. So I don't need to be using hypotenuse, the Pythagoras theorem again. Since I've gotten my r, what I want to look for is the what? Theta. So this is my theta, right? This is the opposite, this is the adjacent. I can just say that tan theta is equals to opposite over what? Adjacent. That is 2. So that is tan theta equals to what's our opposite? That is what? 5. What's our adjacent? That is what? 5 root 3. You can see it gives us the same thing. So therefore our theta is still going to be what? 30 degrees. So therefore this 30 degrees is the resultant to the horizontal. I can also get this alpha. The angle here is alpha. In order to get the angle here, you have to know something, that the sum of angle in a triangle is what? 180 degrees. This is angle 90. This theta is already 30 degrees. So in order to get this alpha, I will just say 90 plus 30. That is 90 plus 30. That is 120. Then I'm going to minus it from 180. That is what? 60. So this simply means that my alpha is equal to what? 60 degrees. So therefore, guys, I can say something. I can say resultant 10 Newton makes angle 30 degrees. This is theta to 5 root 3. Makes angle 30 degrees to with 5 root 3 with the first force. And 60 degrees, you know our alpha is 60 degrees. And 60 degrees to 5 Newton. So let's look at the last example for this particular video. So guys, in this particular video, in this particular example, we say a hiker begins a trip by first walking 2,500 meters southeast. So we have to draw our vector diagram here. We draw the 4 Cartesian points. Indicate the north, indicate the south, indicate the east, indicate the west. It moves 2,500 meters southeast. So this is the south, this is the east. So it is, you know, in this particular question, in this particular one, we were not given the angle. They just say it moves southeast. So we are going to trace it from this middle here down like this. That is what southeast. So this is 2,500 meters. Once you've done this, don't forget that this represents angle 90. So if you should split this, this will be 45 degrees. This is also 45 degrees. But remember that we must always convert all angles to the word horizontal. So the 45 degree I'm going to be taking will be the one to this horizontal. So I'm going to clear this. I will clear this. So that's that, guys. The next one is this. On the second day she walked, guys, this should be 4,000 meters, not 2,500. This should be 4,000 meters. So she walked she walks 4,000 meters in the direction of 75 degrees north of east. So guys, this is north of east. That simply means the angle is between north and what? East. They said 75 degrees. So look at me. This is 4,000 meters. It is between north and east. But they said 75 degrees north of east. You are going to change the term of to what? From. That simply means she walked 75 degrees north from east. It is coming from where? East. So that is why this 75 degrees is going to be here. 75 degrees. So that's that, guys. So that is the only 2 forces we have. So we are going to, after you've done this, the next thing you are going to do is that indicate the positive axis, the negative axis. This up is the positive. This down is the negative y. This right is the positive x. This left is the negative x. Therefore, we are going to draw the table. Horizontal direction, vertical direction. So guys, I'm going to be converting this 4,000 meter to the horizontal direction and the vertical direction. If I'm converting this 4,000 meter to the horizontal, that will be 4,000 cos. Don't forget that for the horizontal direction, I'm going to be taking what? Cos. The angle must always be to the horizontal. If any angle is to the vertical, before you start doing your work, you have to convert that angle back to the what? Horizontal. By minusing from what? 90. So that will be 4,000 cos 75. You now remember that if I should convert this 4,000 meter to the horizontal, will it go to this positive or to this negative? It's going to go to what? Positive. So I'm going to put what here? Plus. This 4,000 convert to the vertical, that will be 4,000 sine. So sine 75. So also, if I should convert this to the vertical, will it go to the positive vertical or negative vertical? That's what? Positive vertical plus. At the same time, I'm going to convert this 2,500 meter to the horizontal and to the vertical. So that will also be 2,500 cos. Whenever I convert to the horizontal, we're going to be taking what? Cos 45. Also, you will now see that if I should convert this 2,500 meter to the horizontal, it's going to be going to the positive horizontal, not negative. Put plus here. I also convert this 2,500 meter to the vertical. It's going to be going to the what? Negative vertical. Minus 2,500 meter sine 45 degrees. So note that very well. Then we are going to look for the summation of x, also the summation of y. So we are going to add the two together. That will be 4,000 multiply 4,000 cos 75 plus 2,500 cos 45. This is going to give us 2803.04. Okay, we will also do the summation y, that is 4,000 sine 75 minus 2,500 sine 45. This is going to give us 2095.94. So that is that. Then, in order to get our magnitude as a resultant, r is equals to square root summation x squared plus summation y squared. R is equals to square root summation x 2803.04 all squared plus summation y 2095.94 all squared. So we are going to press square root 2803.04 squared plus 2095.94 squared. Then guys, our R resultant is going to 3499.9, approximately 3500 meters. We can also calculate the theta, the angle, that's equals to tan inverse summation y over summation x. The theta is equals to tan inverse. Our summation y is 2095.94. Summation x is 280.04. So pressing tan inverse 2095.94 over 2803.04. Then our answer is going to be 36.7937 degrees. So that is the end of today's video. Kindly participate. If you need more questions on these aspects, you can drop your comments in the comment section. I'm going to be dropping more questions for practice. In our next tutorial video, we are going to be talking about kinematics. Make sure you subscribe to this YouTube channel and share this lovely video to your friends and family. Thank you. May God bless you.